Looking at what is meant by linear programming. So it's a technique of optimization of a linear objective function subject to linear equality and linear inequality constraints. So as it is shown, this f of x1, x2 is the function of two variables, a linear function of two variables. Linear means it doesn't involve any quadratic or cubic terms, let's say x1 square, x2 cube, anything like that. And uh, it has the problem constraints of the following form. So these are three linear inequalities which are given to us, and these are some limits on the variables that both should be greater than or equal to 0. That is uh, if we consider them as lying in the two-dimensional plane, then we can say that uh, both of them lie in the first quadrant, that is both are greater than or equal to 0. So as you can see, 1 2 3 4 5 6, so this is having 6 edges. This is a hexagon, so each of these lines are representing a linear inequality, and we want to maximize some function which is represented by this line. So uh, in matrix form we can represent them as maximize ctx and subject to ax less than equal to b, where in this case uh, we can say that A will be a matrix containing A11, A12, A21, A22, A31, A32. X is the vector x1, x2, and B is the single row matrix B1, B2, B3, and X is greater than or equal to 0. So that is the other constraint, and we want to maximize CTX. So C is C1, C2, and X is X1, X2. So these are also two vectors. We can say that B also we can say as a vector because considering it as a single row. So this is the matrix representation of the same equations. Uh, Hope you understood what the linear inequality means. Given some inequalities or equalities, we want to maximize this function. So uh, let's say these inequalities are there, so we can draw them in the plane, and we can see that this is the line representing the inequality. Let's say this one, which I am showing by the arrow. Then in either uh, the answer will lie inside the hexagon or outside the hexagon, so that we can see uh, by the sign of the inequality. So if the inside points satisfy the inequality, then all of the points on this side of the line, on below the line basically, are included. Otherwise all the points above the line are included. So doing this, we restrict the region where our point can lie, the final answer point can lie, and among all those points we want the maximum such point, which is uh, the point which maximizes this given function. So that's about linear programming. Thank you friends, hope you understood, and please like, share and subscribe.